Hey, wanted to summarize what y'all were doing as far as watching that initial video. We had the spring with a hanging mass and basically got it bouncing. I know this is really small on this video. A different perspective. What's up? Okay, I've got this spring, and what is it doing, right, with this mass? It's bouncing up and down, right? It's bouncing up and down. So in this process of thinking, what can you measure and what can you change, etc., okay? Things that we could measure. What do we observe? I've got a spring with weight on it. Like if I don't have a mass on it, it doesn't move, right? If I put different mass on it, right? Is it different, right? So what do I observe? I observe a spring stretching, bouncing with this mass on it. I observe a mass. So I have a spring, I have a mass, and I see it bouncing or oscillating up and down, okay? So bouncing, oscillating, moving up and down. Here is things that I can measure. We've talked about different spring types. I could measure spring types or K values, and you'll notice in the lab that you're getting, I already went through and found a majority of the K values. There's only one spring that I couldn't measure it. So if you see those K values, those can be measured. Other things that can be measured, right, is the mass, right? We noticed there was a difference or an impact. And then what else could be measured, right? The other thing that could be measured, right? This seems to be going through its same path. Maybe I need a heavier spring, right? That's pretty quick. But that phrase, quick, gives us a clue of what we are measuring. Not necessarily the velocity. What would I have to get for the velocity, right, of that spring with that mass going up and down? Well, I'd need distance and I'd need time. So I can't really do a radar gun and say how fast are you going, but I can get a distance and time. Really, what it's doing, it keeps coming back to that same height. What I can measure is the time of the cycle, and what is that called, right? That's called the period. So things, through this process, we're developing these ideas. What do we observe? And what can we measure? And then we've developed an experiment. What can I change are the things that I can control, those independent things. Well, I can measure mass, but I can change mass. And you can see when I change mass, that changes, right, our dependent variable, which is the period, which is the time, right, per one cycle. I hope this shows up on the board. Does that show up on the board? Kind of. Let's see. What else could I change? I could change the spring type. And spring type is a spring constant. And that is that letter K. And that was, gosh, what was it? That was, how many newtons it took to move it a meter. Is that a newton per meter? How many newtons to move it 1 meter? This is in kilograms. But what else was shown, right? What else could be different, right? What could I change in this, right? And I'll use a lesser mass so you can see it in the video. What else could I change, right, to get this in motion, right? I could do a little bit of a, so it's at equilibrium here, well, eventually equilibrium. I could move it a certain distance and get it going. Could I change how far I move it? And will it cause a change? And what impact will that have? It's definitely got more energy to it because I stretched it longer. So I would say, right, displacement. When I looked at displacement, when I looked at your responses, I saw you guys talk about kinetic energy in that motion. Well, kinetic energy has the speed in it, and the speed has a distance in time, and really, period is the time for one cycle. It's completed that distance in one cycle. Period is, right, goes with oscillations. You guys have done sine waves, right? I talked about potential energy. Well, mgh, that has to deal, or 1/2 kx squared, that has to deal with displacement, right? So we don't necessarily have to go to that complex level of kinetic energy or the complex level of potential energy. We take it down to time per cycle, because it repeats a cycle, and then displacement instead of kinetic, like a potential energy. Spring type, I think, was pretty common in your comments, and changing the mass was also. So what I see up here are 3 different experiments that have the period, right? Time per cycle, so seconds per cycle, right? And I see mass here, period, and I see K here, and period, and I see, maybe we might call it delta Y or something, displacement, and you're going to see what you get in your experiment, okay? I hope that helps summarize this process. I hope you feel either encouraged or challenged to think of how you would set up your own experiment as we get into what we call oscillatory motion or harmonic motion. It's actually a pretty cool section. I'm excited to share about it. So let's dig into this, and I hope your lab experience goes well. See ya.